Hello my dear students, I warmly welcome you to CR Digital Classes. So in this lecture, we are going to discussing about the 2 by 2 matrices diagonalization. So far we discussed that the diagonalization of the 3 by 3 matrices. So now in this lecture we are going to discussing about 2 by 2 matrices diagonalization, and we have to find out that the power values a power 6 and a power 8 value. So first of all, see the question. Diagonalize the matrix capital A equal to, we have 4, 2, minus 3, minus 1. So it is a 2 by 2 matrices clearly. Also that we have to compute a power 6 value and we have to compute a power 8 value along with the diagonalization condition. So observe the solution. Given matrix capital A is equal to 4, 2, minus 3, minus 1. The characteristic equation. To find the or to show that the diagonalization of a 2 by 2 matrices. Similarly, as we discussed in the previous lecture for the 3 by 3 matrices. So 5 steps. Those 5 steps also we can write here. Step 1. Step 1 is nothing but to find the eigenvalues of the given matrix capital A. That is, to find the eigenvalues, characteristic equation is given by a minus lambda I equal to 0. So substitute the corresponding values capital A minus lambda I into equal to 0. So take the subtraction and simplify them, you will get in this format. Okay, so 4 minus lambda into minus 1 minus lambda plus 6 equal to 0. Again simplify them, minus 4 lambda plus lambda square plus 6 equal to 0. So if you simplify again, you will get one quadratic equation in terms of lambda square minus 3 lambda plus 2 equal to 0. For this equation, so we can find the factors. So 2 lambda square, you can multiply the first word and last word of that equation, 2 lambda square. The 2 lambda square we have to divide into factors. That means to get that the minus 3 lambda, if you divide into factors, by adding those two factors, we have to get the middle value of that quadratic equation. Here 2 ones are 2, lambda into lambda square. Okay, but if you add 2 plus 1, you will get plus 3, but here we have minus 3. Okay, but so if you multiply with minus for both values, minus into minus plus, 2 into 1 2, lambda into lambda, so therefore 2 lambda square will become here 2 lambda minus lambda gives that minus 3 lambda. So in that format, take lambda common, lambda minus 2, take minus 1 common from the last two terms, you will get lambda minus 2 equal to 0. So from these two terms, lambda minus 2, and from the remaining terms, you can write lambda minus 1 equal to 0. Lambda minus 2 equal to 0, lambda minus 1 equal to 0. So lambda is equal to 1 comma 2. So therefore, in step 1, okay, so the eigenvalues of capital A are lambda is equal to 1 comma 2. This is about to find the eigenvalues. Next step 2, to finding the eigenvectors. This one is the step 2 in this diagonalization process. To finding the eigenvectors. First of all, take lambda is equal to 2. You can also take lambda is equal to 1. Okay, consider a minus lambda is equal to a minus 2i. In place of lambda, just we are substituting that eigenvalue. So a minus 2i is equal to a minus 2i. So if you subtract them, you will get this matrix 2, 2, minus 3, minus 3. Now, augmented matrix is given by 2, 2, minus 3, minus 3, 0, 0. So applying the row operations. Okay, so we have to show that second row 2 is 0. So therefore, to prove that condition, apply the row operations. R2 implies R2 minus R1. Then you will get in this format 2 minus 3, 0, 0, 0, 0. If you apply this elementary row property, then you will get the resultant matrix in this format. Next, the equation is here, this will become the pivot position, and the first one is the pivot column. Next, there is no choice for the pivot position. Only we have one non-zero row, only one pivot position and one pivot column. So then we can apply the solution. So therefore, if you multiply with first row with x1, x2, x3, then you will get 2x1 minus 3x2 equal to 0. 2x1 is equal to 3x2, x1 is equal to 3x2 by 2. So here clearly this x2 is a free variable Then the general solution is given by small x is equal to x1, x2 equal to, in place of x1 substitute that value 3x2 by 2, and x2 in place of x2, x2 it is. So therefore take x2 common, then you will get 3 by 2, 1. Here 3 by 2 is one real number, so we can convert that value into integer. So therefore the eigenvector corresponding to the eigenvalue lambda is equal to 2 is given by v1 is equal to 3 into 2 by multiplying that vector with 2. Okay, so then you will get 2x2 into 3, 2. Okay, so that value we can write in this format. That is the first eigenvector. Next, in step 2 only, second eigenvector for lambda is equal to 1. A minus lambda I, that equal to a minus I. Consider a minus I is equal to a minus I. So subtraction matrix is that one. Augmented matrix exists in this format: 3, 2, minus 3, minus 2, 0, 0. Okay, to do the second row equal to 0. So therefore apply the row operations. R2 implies 3R2 minus 2R1. Then you will get in this format: 3 minus 3, 0, 0, 0, 0. That is the obtained augmented matrix. Now the equation is 3x1 minus 3x2 equal to 0 from the first row. So therefore 3x1 is equal to minus 3x2 if you send that RHS. So therefore 3x1 is equal to 3x2. Both sides 3 3 get cancelled. X1 is equal to x2. Here this RHS x2 is a free variable. Then the general solution is given by x is equal to x1 x2. That implies in place of x1 again we are writing x2. x2 place x2 as it is. So therefore take x2 common, then you will get 1 1 as the eigenvector. That is the second eigenvector. We can consider it as a v2. So therefore the eigenvector corresponding to the eigenvalue lambda is equal to 1 is v suffix 2 is equal to 1 1. In the previous case we have lambda is equal to 2. That here lambda is equal to 1. We got two eigenvectors. Now step 3. Step 3 is nothing but construction of inversible matrix P. That matrix, let capital P is equal to v1 v2. So where v1 is the first eigenvector, v2 is the second eigenvector. Okay, so this column matrix we can take it as a v1. This column matrix we can take it as a v2. Only eigenvectors only columns of the inversible matrix capital P from the diagonalization theorem. And next step 4. Step 4. Okay, here this in step 3 this capital P is inversible. Capital P is inversible. Why? Because det of P is equal to 3 minus 2, that is equal to 1, that is not equal to 0. So det of P not equal to 0, so it is inversible. And columns of capital P are linearly independent. Those eigenvectors are linearly independent eigenvectors. So next step 4, capital D is equal to lambda 1 0 0 lambda 2. So substitute the eigenvalues of capital A. So D equal to 2 0 0 1. మీరు స్టెప్ 2 లో లాంబ్డా ఫస్ట్ లాంబ్డా 1 ప్లేస్ లో ఏదైతే సబ్స్టిట్యూట్ చేశారో లాంబ్డా 2 ప్లేస్ లో ఏదైతే సబ్స్టిట్యూట్ చేశారో అంటే సెకండ్ కి లాంబ్డా ఈక్వల్ టు 1 తీసుకున్నారు. ఫస్ట్ ఏమో ఇఫ్ లాంబ్డా ఇస్ ఈక్వల్ టు 2 తీసుకున్నారు. సో వాటిని సబ్స్టిట్యూట్ చేయాలి. ఎందుకంటే వెన్ ఎవర్ యూ టేక్ లాంబ్డా ఇస్ ఈక్వల్ టు 2 వీ గాట్ ద వెక్టర్ v1, eigen వెక్టర్ v1. ఆ eigen వెక్టర్ ని మనం క్యాపిటల్ P అనే మ్యాట్రిక్స్ లో ఫస్ట్ రాసాము. ఓకే, సో we have to follow that rule amma. Whenever you are going to write the values in diagonal matrix, okay, whenever you are going to write the diagonal entries in the diagonal matrix, you have to follow the property that eigenvectors ఏ eigen value కి అయితే వచ్చిందో అది ఇక్కడ 3 2 అనే eigen vector 2 అనే వాల్యూకి వచ్చింది, 1 1 అనే eigen vector 1 అనే వాల్యూకి వచ్చింది కాబట్టి వాటిని రాసాం. అంతేగాని ఫస్ట్ 1 వస్తుంది కదా అని ఇక్కడ 1 రాసి తర్వాత మళ్ళీ 0 రాస్తే మనకేంటంటే కండిషన్ మిస్టేక్ వచ్చే పాసిబిలిటీస్ ఉన్నాయి. సో హియర్ ఇక్కడ ఆర్డర్ అనేది మీరు ఏదైనా రాసుకోవచ్చు, అక్కడ ఆర్డర్ అని ఇంపార్టెంట్, బట్ అక్కడ ఫాలో అయిన ఆర్డర్ నే క్యాపిటల్ డి కి కూడా ఫాలో అవ్వాలి, అది అక్కడ ఇంప్లై చేస్తాం అనమాట. ఓకే, సో దేర్ ఫోర్ నెక్స్ట్ ద మ్యాట్రిక్స్ క్యాపిటల్ డి హ్యాస్ ద eigen values corresponding to the eigen vectors v1 v2 respectively. Then Here we are going to find that 2 by 2 matrix is diagonalizable. So it is not a big problem to find the inverse of 2 by 2 matrix. Here P is the 2 by 2 matrices. We can find easily P inverse. So formula is, that is the general formula. P inverse is equal to AD minus BC. Okay, D minus B minus CA. Okay, so therefore that is the formula. So now substitute the corresponding values in that formula. Then you will get that where A is equal to 3 and D equal to 1, B equal to 2, C equal to 1, and you can find the adjoint matrix. This matrix is the adjoint matrix for the A, B, C, D. So substitute the corresponding value and simplify. You will get P inverse is equal to 1 minus 2 minus 1 3. It is easy in the 2 by 2 matrices format. Now we have capital P, capital D, capital P inverse. Substitute the corresponding values and first to do the multiplication for these two matrices. Do the multiplication for P into D. Resultant matrix is this one, 6 1 4 1. Next to do the multiplication for these two matrices, then you will get the resultant matrix in this format, 4 2 minus 3 minus 1. What is this? Capital A only. Okay, so therefore we got the required condition, PD P inverse is equal to capital A. So hence capital A is diagonalizable. Condition satisfied now. So actually it is RHS. RHS value equal to, we got LHS. So therefore LHS is equal to RHS. So therefore capital A is diagonalizable. In this format we can show that. Or else instead of doing this inverse process, you can also simply do that P into D is equal to P into A. Already you know very well about that condition. Why? Because we have P, we have D, we have capital A. That is the first part of this problem. Next, they are asking that find the A power 6 value. Here, since we have capital A is equal to PD P inverse, then A power 6, apply power 6 on both sides. Then A power 6 is equal to PD P inverse whole power 6 will come. That 6 is only applicable for the diagonal matrix capital D. Why? Because in the definition of the diagonal matrix, we clearly discussed that capital A is similar to capital D only, not P and P inverse. To do the similar condition, we are using P and P inverse. Capital A is similar to the diagonal matrix. To do the similarity, so we are using P and P inverse. So that is only. So don't apply the power for capital P and don't apply the power for P inverse. Okay, only apply that power D power 6. That is the formula only, you know very well. So therefore A power 6 is equal to, substitute the corresponding value, substitute capital P value and D power 6 means you can also apply the power 6 for the diagonal entries also and P inverse as it is. Then calculate them. You will get A power 6 value as this one, 190, 126, 189, 125. This is the A power 6 value. Okay, so in this format you can find any power value. Why? Because these types of problems have been repeated in the previous examination. That's why we are discussing now. Okay, for the examination purpose are very important. Next problem is A power 8. Same process only. They are also asked in the examination, find the A power 8 value. So apply that A power 8 is equal to P D power 8 into P inverse. So you know very well P value, D power 8 and P inverse. So if you simplify them, first to do the multiplication for these two values, then after that you can do these two values, then you will get the required condition. A power 8 is equal to 766 510. Next to minus 765 minus 509 is the A power 8. Okay, so in this format we can prove that any 2 by 2 matrix is diagonalizable and we can find the power values of the given matrix. Okay, in this process the main important case is whenever you are going to construct in the inverse matrix, that is capital P, follow the rule. మీరు అక్కడ eigen values ప్లేస్ లో ఏవైతే ప్రాసెస్ ని ఫాలో అయ్యారో డయాగ్నల్ మ్యాట్రిక్స్ రాసేటప్పుడు కూడా అదే ప్రాసెస్ ని ఫాలో అవ్వండి. సో కన్ఫ్యూజ్ అయితే మీకు ప్రాబ్లం ఇబ్బంది అవుతుంది. సో therefore this is the total explanation of this lecture. I hope you understood this lecture very well. In the next lecture we are coming with next topics. So make a perfect practice, prepare well. Until bye. Thank you.